This video is a continuation of yesterday. We are still looking at the rational root theorem. And on the previous video, what we did is we filled in this table up here. And ultimately what we decided is that -1 is a rational root of this function because we ended up with 0 when we typed it into our calculator. But what we're going to do is we're going to try to come up with a method today where we don't need to try all of the possibilities to find a root. And the steps that we're going to use to find our roots are that we are going to use, I mostly use synthetic division. But if you love the long division, you can use long division. And we're going to use synthetic or the long division to help us factor the polynomial. Remember, when we end up with the remainder of 0 is when we have a factor of the polynomial. Then the next line, I wish I would have written it just a little bit differently, but it says continue finding the roots and dividing until we have a second degree polynomial. That's really important. And it's important because once we get something into a second degree polynomial, then we can factor or use the quadratic formula. And some of you are finding that the quadratic formula is better for you than the factoring. And that's going to help us find the remaining roots. So when we switch over here to our examples, I still want to talk about the rational root theorem. And the rational root theorem goes back to the p's and the q's again. The p is the constant term. The q is the leading coefficient. And we're looking at the factors of those. And a memory technique, which may or may not work for you, is quarter pounder. So, again, P is the constant term and Q is the leading coefficient. So when we look at the factors of 2, our factors are 1 and 2. 1 times 2 is 2. The leading coefficient has a few more factors. 1, 3, 5, and 15. Because 1 times 15 is 15, and 3 times 5 is 15. And once we determine those values, we can come up with the possible rational roots. And every teacher kind of has a different pattern, so to speak, but we all eventually get all of the roots listed. I just start and I say 1 divided by 1 is 1. 2 divided by 1 is 2. 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 1 divided by 5 is 1/5. 2 divided by 5 is 2/5. 1 divided by 15 and 2 divided by 15. And remember, with all of those roots, it could be plus or minus. And because they're all plus or minus, that's a lot of roots to guess and check. I mean, it limits it, but do we really want to guess and check 16 times? And I think that the answer is no. So what could we really do instead of testing each possible rational root in the equation until you find the root, is we can pull out our graphing calculator and let's type in that function. We're going to go to y equals, and we're going to type in 15x cubed minus 32x squared plus 3x and plus 2. And when we type this in, we can either look at the table or we can look at the graph. I tend to look at the graph, but both of them are good choices. But I'm going to hit graph here. And as we look at the picture, what we're hoping to find is we're hoping to maybe find a root that we listed here. So it says test each possible rational root in the equation until you find a root. So my screen is small here. I can actually pull the calculator back up. Is there a value up there that we can identify right away by looking at the picture? Not -2. 1, 2. So we think possibly that one of the roots is 2. How many roots are we looking for in this equation? We're looking for 3 roots. So 3 roots, and one of them is 2. So we're going to use synthetic division to figure this out. Again, if you prefer to use long division, that's fine. But as we factor the polynomial by using synthetic division, when we set this up, it's going to be 15 minus 32 plus 3 plus 2. And then we think that the root is 2. So we're going to use 2 in our synthetic division process. Don't change the sign there. Because it's not written as a factor, it's written as a root. And we're going to carry down the 15. Now we can clearly see on our calculator, even though it's a small picture here, that 2 is a root. We cross the x-axis at 2. So we better get a remainder of 0 when we do our division. 2 times 15 is 30. It's positive 2 times positive 15. Negative 32 plus 30 is negative 2. 2 times negative 2 is negative 4. And 3 minus 4 is negative 1. 2 times negative 1 is negative 2. And 2 minus 2 is 0. And sure enough, we do end up with a remainder of 0. And we should. So what that leaves us with then is it leaves us with the polynomial of 15x squared minus 2x minus 1. I kind of went a little bit fast on that. I'm going to digress here for a minute. Remember that we started our polynomial, we started with x cubed. And when we divided by that 2, that was a first degree. It was x minus 2 to give us the 2, which means that our answer then is going to be 1 degree less than what we started with, which is why I filled in an x squared here by the 15. And what our steps say is it says use synthetic division to help us factor until we get a second degree polynomial, a quadratic. Because a quadratic allows us to factor or use the quadratic formula. Do you have any preference here on this in terms of how to solve? Do we want to factor? Do we want to use a quadratic formula? And I would factor. And when we factor, I'm going to slide divide. If you like the quadratic formula, if that's your method, use the quadratic formula. So we end up then with x squared minus 2x minus 15. 15 times 1. Now we have a coefficient of 1 on the x squared term, which makes it easier to factor. We've got x minus 5 and x plus 3. Again, I seem to be going a little bit quickly here. But the factors of 15 are 1 times 15 and 3 times 5, and we need to combine to be 2. So negative 5 plus 3 will give us negative 2. And negative 5 times 3 will give us negative 15. Don't forget to divide. We slide, so now we need to divide. And now, what happens is, when we simplify this, we get x minus 1/3 times x plus 1/5. What we're looking for is, we're looking for the rational roots, and we can use these roots to solve here. I know you're probably running out of space on your paper, but we're going to take x minus 1/3 and set it equal to 0. So we can add 1/3 to both sides. And we get x equals 1/3. We're going to take x plus 1/5 and set it equal to 0. And when we subtract 1/5 from both sides, we get x equals negative 1/5. I hope that you don't have to do those two steps there where you have to subtract, but there's nothing wrong with it. We do want to list our roots here, and our roots are the 1/3 that we just found, the negative 1/5 that we just found, but you told me there's 3 roots. What's the third root? Or the first root, depending on how you look at it. It's the 2 that we found when we did the synthetic division. Don't forget to write all of the roots. Now, these are rational roots because a rational number is any number that can be written as a fraction. We can have irrational roots, which means that there's a radical as part of the answer. We can have imaginary roots, so we have an I as part of the answer. Today we're focusing in on the rational roots. So as we finish these, apparently I forgot to scan this last question in, but we're still going to use the rational root theorem to solve. 3x cubed minus 13x squared plus 2x plus 8. And I can recommend that we start with the rational root theorem. Rational root theorem being the p's and the q's. And when we look at these factors here, because that's where they're coming from, by the way, the memory technique that might work for you is quarter pounder. But the factors of p, factors of 8, are 1, 2, 4, and 8. The factors of q are 1 and 3. But what we really care about is p divided by q, because those are going to be the possible rational roots. So 1 divided by 1, 2 divided by 1, 4 divided by 1, 8 divided by 1. But our other possibilities are 1 divided by 3, 2 divided by 3, 4 divided by 3, and 8 divided by 3. And they can be positive or negative. As an aside, sometimes I just put parentheses around there and put a plus or minus in front of it. So that helps me remember that it could be either or. But now that we've got that, let's go ahead and type that function into our calculator. So 3x cubed minus 13x squared plus 2x plus 8. And let's look at the picture. You can use the table as well. But can we identify any roots or roots from this picture? Looks like 1. We also have 2, 3, 4. But really on this one, we only need to identify 1. That's going to help us enough. how many roots are we looking for? 3 roots. Our highest degree term is in x cubed. It's a cubic function, so we should have 3 roots. The first root that we saw was 1. So we're going to synthetically divide now in our polynomial. And we have 3 minus 13 plus 2 plus 8. Let me just check that real quick. 3 minus 13 plus 2 plus 8. And now here then we're going to put the 1. We bring the first term down and we synthetically divide. Again, if you prefer long division, use long division. It is 1 times 3, which is 3. And negative 13 plus 3 is negative 10. 1 times negative 10 is negative 10, and 2 minus 10 gives us negative 8. 1 times negative 8 is negative 8, and 8 minus 8 is 0. Again, if we can see that it's a root on the calculator, we better get 0 for our remainder. We started with an x cubed term. That means when we divide, we're going to end up with a degree 1 less than what we started with. So now we have 3x squared minus 10x minus 8. Do you want to factor or do you want to use quadratic formula? And again, it does not matter to me. Okay, so if we factor again, what we're going to do is we're going to slide divide again. There is nothing wrong with using the quadratic formula. So if we slide x squared minus 10x minus 24. So it's nice. Now we don't have any number in front of our x squared term. And the factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Be careful, because 12 minus 2, or 2 minus 12 is negative 10. Negative 4 plus negative 6 is negative 10. Which factors do we want to use? 2 and 12. And again, it was plus 2 minus 12. Don't forget to divide. We slide, so now we need to divide. We really don't need to do the bottoms up part of this. We end up with x plus 2/3 and the x minus 4. And hopefully you can tell me that x equals negative 2/3 and x equals 4. But if you can't, all that we did is we took x plus 2/3 and we set it equal to 0. So we subtract 2/3 from both sides to get our x equals negative 2/3. Just what we said there. Same thing with the x minus 4 equals 0, and we can add 4 to both sides. We get x equals 4. Sure enough, there's that. But one more time, we said that we're going to have 3 roots. There's our 2. What's our third? It's the value that we originally came up with, which is the 1.